Hello everyone, and welcome back to Stationeers. I'm level 36, and today we're going to continue working on fixing my automation after it got blown up by my spare coolant tank that we forgot about. So, last time we had kind of set up the beginnings of our chute network to make sure everything went the right way and got to where it needs to go. It also built our toolmaker and our rocket print over here. Haven't used the rocket print yet, so I'm excited to see how that all works. In between episodes, I ran the last few shoots just kind of between everything. I welded up the floor so you can actually walk around a little bit. Not all of the floor yet, though, because still need to run around and do a few things. So just to kind of recap, so previously we had this all automated by essentially using these digital chute valves. Can't see them from this side. We hop down through here, yeah. So you can see each of these digital chute valves. We used these along with some ICs to, or not ICs, regular logic circuits to only send, oh jeez, my whole person's falling apart, to send materials to the manufacturer when the manufacturer was on. Oh, also, I think, yeah, this is all done processing. So we've got a whole bunch of good stuff in there. So we'll unleash this into our system either when we need it or once we're done, because I actually don't want to fill it up with a whole bunch of crap while we're still not having the automation done. But these those flip-flop sorters or flip-flop valve, what are they called? Valves? Splitters? Splitters. Flip-flop splitters are were kind of dumb before, because, like, say we had a setup like this where we had all three of our workbenches on, or even if we just had the Atmos print on, we were working in the auto lathe, all of the resources from the vending machine would get sent to the pipe bender by default, instead of going to the auto lathe, because this was first in queue. So since this was on, everything automatically got sent here. We know in our IC chip when our system is requesting something. So let's just do it that way. One of the things I've tried to do is just use the 6 device registers on our circuit housings themselves. This might push it for devices, because technically each device or each housing is going to have a, so 1, 2, 3, 4, 5, 6. That was the auto lathe. That was the bloody vending machine. The button, the dial, the LED, and the stacker. So 1, 2, 3, 4, 5, 6, 7. Okay, yeah, 7. 7 devices if we still want to use these LEDs, which I kind of do. They're neat. So in that case, we are going to need to use a set hash name or something like that. So, not the end of the world. We'll probably use the stacker for the set match name. Shouldn't pose any problems. Maybe it will. Well, no, that should be on the separate circuit. And we'll see, one way or another. Or we could just roll without the LEDs and just... it'll be fine. I don't know. We'll see. We haven't gotten there yet.
Hydration critical.
Okay, my guy's complaining about everything. I guess we gotta go take care of myself and grab our laptop because we are gonna do some IC programming. Check on our potatoes as well, see how they're doing. Take my suit off quickly just to get the benefit of not having a suit on for a minute. Ooh, potatoes look grown. So they're... Geez, we need more CO2 already. So these are not seeded yet, so I kind of want to wait until they seed. Here, gas canister. I thought we set your pressure lower. In fact, I could have sworn we set your pressure lower. Apparently we didn't. Oh, jeez. I gotta remember not to drop these. I don't know what about the floors makes this so sketchy, but... seemed fine. I don't know where the nitrogen and the oxygen came from, but... yes, that pressure is okay. But it's a little high for what I want to be releasing into this room. Because this is something like... 500 moles of that. So I'm going to try something cheeky here. We have this gas canister of propellant, right?
Critical.
If I do this, we are releasing CO2 into the air. A very small amount of CO2. It's kind of funny, though. Yeah, that's done. Also, while we're here, we might as well top off our nitrogen tank.
Jetpack critical.
Just gonna pop that in there. We'll put our suit on just in case this is a less than... Let's not jump down the hole without our propellant canisters. That is our only way of getting back up right now. Now the potatoes are happy. I open my mask. Not blacking out. I wonder if it says how much CO2 actually is a problem. Nope. eat our remains of the last couple cereal bars. Our light system seems to be working fairly well. All is well. Oh, I forgot my laptop. Dang it. So I go try and find it. I know where it is. Jeez. Yes. Yes, I need my laptop. I'm excited. I don't know how soon it might be a thing, but I heard that these like consoles, we might be able to use some kind of Lua scripting at some point to write our own interfaces for them, which would be pretty neat, not gonna lie. Still growing. We're gonna put our laptop in the elevator, just in case we get a dust storm. It shouldn't fly out of in there. First things first, we need to do some naming. So, hydraulic pipe fender, that's fine, that's fine. We're also going to need some more consoles. No, turn off. Some more buttons and some more dials. So those should be switch, logic switch. Get some gold. I did also put the lights back up. There's some more copper. Yeah. Not make another 100 of these, but we'll need a few. We'll need some consoles and some hash displays. Yeah. We still have one button there. Also gonna need some walls. Deal. One, two, three, 4, 5, 6, 7, 8 switches. What? 7. Go. Make a couple walls. As well. For the buttons to sit on, and then for these, I'll need some plastic. And some glass. There we go. Alright, with that, now we need our fall through the floor real quick. Dial. Button. Can't wait to fully seal up the floor. One's going to be another one that's going to be fun to get at, but only so much I can do. And then we need some consoles. Console. We'd only need 3 of these. Hash display. One more console. And one more hash display. All right. You're in sideways. We are going to need to place you. Cool. Glass over each of these. Now we need to wire it all up and the LEDs as well. I forgot about those. You're already fine. I think we'll write the LEDs in as optional, actually. Oh, and we do need to get power over here from somewhere. We don't actually have any power over on this side of the room. That's okay. Pull it on this side. Yeah. Yeah, we'll do straight through just in case. have... So our transformer's right here. Gotta have our power source somewhere nearby. I can actually just tear this wall out without any consequence. Yeah, we can just run a cable. Right off of that. Yeah, that's right. Doesn't actually power anything through there. Now these should work. What kind of madness are you gonna actually need? Probably nothing terribly unexpected. Yeah, no, this is all stuff that I kind of could have predicted. Alright, so now we've got power over there. Let's just power this again real quick. Silly as this looks. Even though this does not currently go anywhere, because that whole system is still broken down there, we'll have to fix that soon. Cool. Now everything is on the same circuit. We've got all of our switches, all of our buttons. We do not have the LEDs yet. We built these without walls. More walls. Hey, it's needed. We need walls. In fact, we need a lot of walls. I would like this room to be enclosed once more. Plastic sheets. Out of plastic sheets. Dang it. Don't fall through the floor again. It's gonna take silicone. It's not the silicone. Alright. We need some more cable coils as well. How much copper do we have? There. 3. While we are waiting for that, let us actually do the naming now. So this one is flip-flop splitter. Oops. This one goes to E. Hydraulic pipe bender. Electroprint. Autolathe. Ow, we missed some shoots. There's none on that one. Okay. Now we need to name all this stuff. Electroprint. Dial. EP. B. Dial. P. Button. H. P. K. Could be the last thing we need to actually get down there for. So if we grab our iron sheets and our welder. Now stop myself from sinking through the floor every time I walk around here. Ah. Very nice. And we'll leave that one open just in case we do need to get down there quickly. We can also do this one. We can put that one up all the way, I think. So, how do we want to do this? We are going to need our IC housings. Never did get my lap. Oh no, I did. I threw it in the elevator. So we're going to grab this one. Let's take a look at our program. What we did, how we can improve this. So the fabricator is device 0, vending machine is device 1, activate button, qtyDial, statusLED, and stacker. We are going to change the stacker out. So we're going to define fab stacker. Oh, that's right. We need to do hash. This is going to actually be litter as device 5. So we are going to get rid of that because we shouldn't need that anymore. Set vending machine lock to 0. Clear that. We are gonna erase the fabricator's memory.
Hunger
I need
caution.
to remember how, and we need to grab some food and water. I need to remember how to set a flip-flop splitter to just bypass. Like where it only flip and flops when I want it to. We should set the upper limit on this a little higher. That is going to pressurize that canister there, which we don't want to necessarily overpressurize. Ah, these are done. Good. My seats go. Blown off the top there. Potatoes. Glorious homegrown food. No more granola bars for me. Plant these using potatoes. Yeah, it's been on the floor now. Hey! Close enough.
Hydration critical.
Good, this is exciting. We've got our food working again, so we are actually somewhat safe. How can I short cycle this? I don't think I can necessarily. So if I do, I'm just going to vent it to the outside world, which I don't want to do. I'm going to reconfigure it so that it overpressurizes a little bit, or just ups the pressurization. So I remember to do it. Oh. So. We need to be able to tell so order of operations is going to be important here because we do have this main flip-flop splitter here, which is our kind of this one's one, which I don't remember what I named it, which is going to be a pain because I need to know. What happens when you get overconfident with things? Well, we need this anyway. Oh, I know what I'm doing. Definitely not going to forget immediately. What are you called? Tool and Rocket. So we are going to need to set Tool and Rocket flip-flop splitter to be straight through. If we look at our digital flip-flop splitter, we have mode and setting, which are the two that I know we need to mess with. I think setting is... I should be able to just look it over here, because this is what we did over here as well. My memory of IC10 programming is not always the best. Nope, that's not the right one. That's why it's not working. Ah, I finally figured it out. I'm using a name, a batch name. So when I said this was new, that's why the iron hasn't been dispensing properly. Ugh. Well, glad I figured that out finally. Quantity 0, mode 1. So mode 1, I think, is the bypass? Setting 0, mode 1. And then request complete, set outflow mode 0. So we need to use mode to switch it. Setting is the... how many to n it is. It's like 1 to n. So we need to do... select the button. Go. We're going to do set split. Actually set batch. And if we do all of our splitter flip-flops rights, I think. I hope. We'll see. On true. Setting 0. Unknown at line 15. Oh, it's probably because we like never wrote it. What did we do wrong? There's nothing at line 15. It's a comment. See if we comment this out, if it gets happier. Line 16 now. What in the world did we go wrong? Oh, we don't have our vending machine configured. Okay, that makes more sense. Be all the way at the end. Still something's wrong. You have a status LED. Like you're set correctly. I think. What in the world is going on here? What's wrong with line 17? Set status LED to on. Oh, is it not connected? That's what that is. Okay. I forgot. We were still kind of setting things up. Yeah, none of these are actually wired in. That would explain that. There we go. Should now actually function properly. Now all of these should hopefully be... That one is. Rip out some more flooring. I think you might be the other type. Which is actually somewhat convenient, because we don't actually need the name of it then. Okay. So if we grab you... and we set batch left... on setting 0. Let's just set to, for default, everything as straight through. Set batch, grab that, and mode 0. You're going to be wired in, right? Yep, okay. Boop, boop. Still not on. You're still not turned on. What is wrong with this? It. Keep forgetting that. Now that is set as straight through. Put this back. So now everything should be set straight through. Let's see what updates we need to make. First of all, I want to alias filter I don't think R14 is the return address. This should not break anything now. This is going to be ours. Lit. And let's also move clear up to the top. Turn it on, set the status LED to on, setting to 1, code to 50, vending machine lock 0. Let's also turn the vent. I don't know why we're doing the lock. Let's just do the on to 1. Oops. I wonder if the other side is also the one. You might want to use batch name because that would be a bit awkward. This is probably is also type that we don't. We should use set batch name. That's what I'm coming to the conclusion of. Just gonna get rid of these comments. So we're setting them up all the same. Fine. Cool. Cool. And it's hash of called back. Okay. So this is what we were doing before, and we have a lot of stuff just dumped into our main loop. Like, this is a really poorly written program. Yeah. So this was one of the first scripts I actually wrote, so I think we're gonna go through and do some cleaning up. First by actually making main loop with no operations in it. We are going to call this get hash. Display the fabHash is neededHash. this was so weirdly organized. These yields. So at least I left myself some comments, because geez, this would be impossible to filter through otherwise. This is still confusing. So I'm trying to walk through. Sorry if I'm not saying anything. So this get hash function, we are getting from the fabricator the 54th slot, or the 54th memory address is always the needed hash for that fabricator. And we are so if there is a needed hash, we're branching to request. If not, we are loading the load fabHash, the recipe hash. So this is what we're doing to display the recipe. Also, this light color crap is we did this all wrong. So in the main loop, the first thing we are going to do in the main loop is check is the get hash function. And then, so we are going to jump, what is it? JA? JAL. So this is going to store line number into the return address. If we need a ingot, we are going to request it using request, and request is going to jump to the return address, which will be the return address of this, and we're not going to load the next thing. Because this is not a BNEZAL. If this was BNEZAL, this would jump back to here. Instead, we are doing this and jumping to return address, which will be the next step there. We're just going to get rid of the light color stuff for now, because I'm going to deal with that somewhere else. So this, if a ingot is fired jump to west without set. All this does is we set our own setting, we request it, and we get the thing back from the vending machine. End request, this was a dumb label. Like, it was fine for the time, but okay. This needs to be check activate. That's what we're going to call that. Only yield is going to be at the end of this. L activate. Activate seems to be a reserved word. Activate FAB. That makes more sense. Get rid of all the light color crap. Okay. So activate FAB. We load R1, activate button setting. If it is 1, we jump to assemble. If it's not, we jump to return address. That is fine. I guess that can be its own function. If we need space, we'll reclaim it from that, but I don't think we're going to. So in theory,
Air tank low.
that is everything that needs to actually be in here. Request is where we're going to need to do some more stuff now. So before we send this request to the vending machine, we need to... What is the current thing? Set mode 0. So we're going to... that. In fact, we're going to set this up as a subroutine. Set splitters. So we are going to basically clear in fact, because this is a section we're going to have to set up each time, we're going to move this up to the top. Filters. Fine. So this resets all of the splitters to kind of their main. That's not going to work at the top. Because it will hit JRA and they go, what are we doing? This is going to get more complicated. So just as an explanation, even though we're an hour into this, I'm sorry. If we didn't have that tool and rocket splitter, this would be a much more simple system. But because we have the tool and rocket splitter, we have to divert or undivert our main feed line over there or back. Which is making this much more complicated. Because if we didn't have to do that, we'd just be able to either set all of the splitters to send and then set this one to, or we didn't even need to exactly do that. We just set this one to, hey, accepting ingots,
Hydration
then
critical.
not accepting ingots when we either get our ingot or we're done. Because we can't just do that. We have to, first of all, name the Let's set the mode 0. So this. That's. That's 8. Then we are going to set our split. 1. This feels silly to do over there, so actually we're just going to do this in here. Because we don't need a separate subroutine for this. Okay. So we set our to mode 0, the diverter to mode 0, we set splitter to mode 1. We get our stuff from our vending machine. We set our splitter mode 0. Or no, we can do that after they sleep. Then we jump to the return address. Should be up here. We yield. We did that. Need some water. Pressurizes all the way. Plants are growing well. Finish off our potato. Grab some fresh oxygen while we're in here. Oh, I really want to get this done before the end of this episode. I need to make an actual tutorial for this, because it's a really cool system, but unfortunately the deployment of it in my situation kind of sucks, with the 2 assemblers being out of line. I mean, it's good to show this, because like now y'all can also set it up if you want to set it up with 2 out of line or 3 out of line or whatever configuration of splitters you want. So, you know, if you're watching along, you can get what I'm doing with the program. I'm trying to explain it. So neededHash, sleep 5. Okay. So this should, in theory, send stuff to the right place. What I do want to do is set up the light. So by default, whenever we're not doing anything, we want the light to just be off. Let's actually remove the just turn on section. So when we're getting the hash, we need some kind of state system. Maybe we don't care about the light right now. Let's just actually see if this works. Just make sure everything should be set up correctly. Confirm export. Oh, we didn't do the stacker thing. Okay. Goes down. here we set the stacker. So we're going to set, again, set batch name. It's not great. I hate doing this, but when you need more devices, that's what you do. There are 2 stackers. 2, 3. Oh, good, there is. What's different about you? Which one are you? Their visual difference? Yeah, that one has the arrow backwards. Which one do we have? Arrow forward. Copy that. Stacker. Labeler again. Let's see. Just say I want 1 plastic sheet. And we're going to need a couple shoots. That's hooked up, and we're going to need one here as well. I would like 1 plastic sheet, please. Boop. Worked. It worked. Huzzah, it actually worked. That's kind of impressive, actually. So theoretically, the point of the LED is it's supposed to display the status of the fabricator. Mostly, if we're actually out of something, I want it to flash, because I want it to say, hey, you're out of something. It'd be nice if when it was actually operating, it was green, but that's going to be a little harder to input. We really don't use many of our registers. Alias, lastHash as R9. I'm not using that anywhere in the script already. So when we get the hash, or actually it's when we request. So when we make our request, we are going to create item counter and status. If we can actually get this. So if we go to it, this is going to be Let's see what the outputs from this are. Okay. Manufacturers. Look at the completion ratio. Maybe activate. I think activate is what we can look at. We're going to set up another. I'm going to get rid of some empty space. Well, no, empty space is fine. We're going to set up another routine in here. It's going to be update light. In request, what we're going to do is we have the needed hash now, so we're going to branch relative equal, branch relative not equal. Relative branch to line C if A does not equal B. So if A does not equal B, so if needed hash does not equal last hash, we'll go forward, X number of lines. We'll set that first for 2 for now. So if we make a counter, yeah, R14. In fact, I want this to be R8. No reason to use such high registers because I'm not sure actually where the return address register is. So we're going to move, or we're going to first add we actually want branch relative equals. Because if this no, we wanted not equals. If it's not equal, we're setting it because that means the request has changed. Everything's fine. Set count counter 0. 2, that should be fine. Right. My brain's failing me here. Need a sticky note real quick. Some things it helps to have a little bit of paper to help with. Because if the request is equal, we want, if they are equal, we want to increment the counter. If they are not equal, we want to reset the counter. So these are not equal, so we reset the counter. What's a branch? Could be 1, 2. Branch relative equal. Add to, or no, it should just be 2. We'll just do add counter 1, so that is a just increment. Then we are going to move into lastHash B. Hash going to light. You don't actually need update light. That's what we're going to do. This is also to kind of error correct because we want to cancel the assembling if we actually don't have the thing we need. So we will now branch relative equal counter. Let's just say we have 5 loops where it doesn't work. Just gonna jump 5 this time. We've got these switched because if these are not equal, so if they are not equal, we don't want to branch. So we want this one to actually be the equal, this one to be the not equal. There we go. And then we want this one to be not equal, so because we only want to branch if we only want to run this section of code if counter equals 5. So in here we are going to set the red clear fab set fab lock 0 open. I think open is one of them.
Hunger caution.
1. That should reset everything. Actually, just jump back to main. This is 1, 2, 3, 4, 5. Let's just make this 6. Just in case. We might still need to update LEDs because when we activate the fabricator, here's what we're going to do. In activate fabricator, we're going to set that this LED 1, set the color green. That will make the LED green. When we activate it, it'll turn red if it errors out. Yeah, that should be fine. Let's just see if that works. Oh, great. Something. And the error has already reappeared. So let's, because we only have a little bit of silicon left, let's request like 20 of those. Here we go. Silicon, light is green. 1. Oh, we need more silicon. Take like 30 seconds or so. Maybe. Light turned back to green almost immediately, but it did pop that open. Oh, at least this has got reset. Why did the light turn green again, though? Oh, because this needs to go. Okay. That was being run every time. This needs to just go at the beginning of the sample. There we go. Now it's green when it's assembling. We'll even do something fancy here. We'll color below.
Hydration critical.
0. There we go. That should now work better. Alright, so if we do this, hey, I want these, I know I don't have them. Oh, it's set it back to 1. That's fine. So that's locked. Could go. Counter. We probably pushed it out of range. Dang it. Yeah, it goes 1, 2, 3, 4, 5, 6, 7. So let's just go to like 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Fine, just for safety's sake. That yellow, so it's requesting something. Splash the screen for a second because it finished the wait period for that. Last one. Good turn. We'll only do this 5 times. That neck.
Waste tank caution.
It's gotten goofed up here. It worked fine just but a minute ago. Counter equal to 5. So if counter is not equal to 5, let's do, I mean, maybe if counter less than branch relative less than if counter is less than 5 branch. Just immediately went red. Oh, because we're not ever resetting the bloody counter. Okay, that's why. When we push the button to assemble, we need to set our counter to 0. Counter 0. Move. This should, I think, fix it. Boop. 1, 2, 3, 4, 5, and aired out, opens up. That'll stay red until the next time we activate it. Awesome. That's cool. It works. Let's go eat our other potato and drink some water. So, our system works. Yay, that's actually exciting. I'm going to roll that out on the other assemblers, but we have our assemblers automated again. That is gonna be nice for continuing building, because that was the biggest thing that got wiped out. Like, as much as it kind of sucks that all of our stuff got wiped out, it's not that bad. Like, not great for sure. It's not the end of the world. And it's been kind of nice now that we have to do some extra thinking about how to make everything work.
Hunger critical.
And we've also had the opportunity now to fix our wonderfully broken, not broken, but working not as intended script, and add in 2 more manufacturers. So yeah, I think this is overall good. And probably between this episode and next, I'll put in the walls over there so we can work on repressurizing this area and getting the downstairs put back together, because we haven't done that yet. Then we can finally finish the stupid filter change project. There's never an end to the projects needed to be done, but I feel like we've made some good progress. Ooh, we're actually almost out of nitrogen again. That is probably because we are done pressurizing the room. We are just building up pressure in here. I'm okay with that for now, though, because we need that pressure for repressurizing the rest of the base. We are going to probably want to set up a limit to how full that'll get before we cut this out, and then we'll need to also set up our CO2 injection system so that there's X percentage of CO2 in the air. We'll have to, there's a lot to do. First of all, let's finish cleaning up after the explosion. Anyway. Thank you all for watching. I hope you've enjoyed. If you've seen something obvious that I've done that's been silly, that I should probably fix, or if my program just kind of is a mess, I know it's kind of a mess. I was trying to read it there. It's definitely a bit of a mess, but it's a mess that we can work with. Drop some comments down below if you think of anything that needs fixed, and I'll see you all next time. Thank you again for watching, and thank you for your support.